my name is Aerodynamic, and I've made an advanced academic aerodynamic video series for you. This video series consists of Bernoulli's principle, the Venturi effect, and the Coanda effect. Hopefully these videos will enlighten you in these principles and effects. Daniel Bernoulli was a Swiss mathematician and physicist who lived from February 8, 1700 to March 17, 1782. He is best known for his work in the field of fluid mechanics and his work involving probability and statistics. Bernoulli's principle states that for an inviscid fluid, in this case being air, an increase in velocity of the fluid, air, occurs simultaneously with a decrease in pressure. Hi, my name is Aerodynamic, and today I'm going to be conducting a simple experiment which will demonstrate Bernoulli's principle. In order to conduct this simple experiment, though, you have to have four materials: a spool of thread, cardstock, a straight pin, and an electric air pump. In order to start this experiment, you got to put it together. So first, take your cardstock and find the center. What I did is I drew an X and took the center point and poked a hole through it so that you can fit the straight pin through. So after that, you're going to have to just take your spool of thread and stick it on top. And now you are ready to start your testing. What I'm going to do is I'm just going to stick the pump on top of the spool, and after I've stuck it on top of the spool, I'll turn it on, and then after I'll release the cardstock, and it should stay up. So now I'm just going to stick it on top and turn the pump on. Now you can release it, it still stays up. Pump off, there will no longer be the velocity to keep it up, and it will fall. The way that Bernoulli's principle relates to my AAA wing system is that I have three sets of jets over top of the wing that shoot the air at a higher velocity than the air that is currently going over the wing. And since I'm shooting it at a higher velocity, it has lower pressure than the normal air, increasing the lift since you have higher pressure on the bottom and lower pressure on the top. Thank you for listening to my advanced academic aerodynamic video. Hopefully you enjoyed the video and it helped you learn more about Bernoulli's principle. Later you should check out more of my videos on various other effects and principles. Giovanni Battista Venturi was an Italian physicist, a diplomat and historian of science, who lived from March 15, 1746 to April 24, 1782. He is best known for the discovery of the Venturi effect. A number of inventions are named after him because they use the Venturi effect in their design, such as the Venturi tube, the Venturi flow meter, and the Venturi pump. The Venturi effect is the reduction in fluid pressure that is a result of a fluid flowing through a constricted section of a pipe. Hi, my name is Aerodynamic, and I'm going to be showing you a simple experiment that clearly demonstrates the Venturi effect. So with this experiment, you need a few materials in order to conduct it. So some of the materials that you're going to need is some painter's tape, double-sided tape, an electric air pump, 2 kitchen funnels, a 30 centimeter by 30 centimeter square piece of cardstock, and also an anemometer to measure the velocity of the air. But with my anemometer, I need to hook it up to the computer in order to get test results, but not all anemometers need to. In order to start testing, first you are going to have to assemble the experiment. In order to do so, you're going to have to take your 30 centimeter by 30 centimeter cardstock sheet and fold it into a cylindrical tube. I've already got mine folded, and this is what it looks like after. So after you do so, you're going to have to run 2 tests. So the first test, you're just going to tape with the painter's tape the funnel to one side and stick it inside your air pump and measure the velocity. But for the next test, you're going to add on this funnel and tape it down to the other end and test the velocity with your anemometer and see how the velocity has changed now that you're forcing the air to go through a smaller area. Now that I'm done assembling, now I'm ready for the first testing phase. So what I'm going to do is turn on the air pump, and then after I'm just going to hit the collect data button, and I'm going to get the velocity readings from this. I took 10 seconds of readings and I'm going to compare them to the velocity when I add on the other funnel. Now that I've run the first phase of the testing, I'm ready for the second phase. I've already taped on the second funnel and I'm ready to start testing for the Venturi effect and to see how much higher the velocity is now that I've added this funnel. So I'm just going to turn on the air pump and then I'm going to start collecting my data for 10 seconds. The data this time was significantly higher, and I will show you in a minute. The red line in this graph is the first phase of the testing, and the blue line is the second phase of the testing. As you can see, the blue line is significantly higher, showing that the velocity was significantly higher. As you can see in the graph, there was a tremendous impact on the airspeed velocity in the second test, and this is due to the Venturi effect. Since you decreased the cross-sectional area, the velocity increased with the second test. It increased by so much. It started off with only a 0.6 meters per second rating when you did the first test, and then on the second test, I got results of all the way up to 3.5 and 3.8 meters per second. So that's a tremendous jump from the first phase of the testing to the second phase of the testing. In my AAA wing system, I use the Venturi effect by installing 3 sets of nozzles which use Venturi tubes. These Venturi tubes increase the velocity so that it's higher than the current velocity going over the top of the wing, decreasing the pressure even more. So by using these nozzles, it helps me achieve that effect. Thank you for listening to my advanced academic aerodynamic video. I hope I taught you more about the Venturi effect. And I hope that you check out more of my videos consisting of various principles and effects. Henry Coanda was a Romanian engineer, inventor, and a pioneer in aviation, who lived from June 7, 1886 to November 25, 1972. He is best known for his discovery of what is called the Coanda effect. This effect has been used in a number of aeronautical inventions over the years. Henry also built what some consider the first jet, called the Coanda 1910, which was powered by a turbine that compressed the heated air and expelled it rearward to produce thrust. The Coanda effect states that a jet of fluid, air, will be attracted to a nearby surface. Hi, my name is Aerodynamic, and I'm going to be showing you a quick and easy experiment that clearly demonstrates the Coanda effect. So, in this experiment, you're going to need a few materials. These materials consist of some painter's tape, Scotch tape, cardstock, a hairdryer, and a cardboard box. In order to start your experiment, first you gotta build it. So in order to build this experiment, you're gonna have to take your sheet of cardstock, and then after you take your sheet of cardstock, I want you to fold it into a curved surface. I've already made my surface, and here it is right here. This is what it looks like. And I just attached it together using the Scotch tape. And after you've got your design already made, you're just going to want to tape it using the painter's tape to the top of the box. And then you want to take your hairdryer, fold it up, and then tape that down in place. And then you're ready to start your experiment. Now that I've got the hairdryer taped down, I'm ready to start my testing. So what I'm going to do is I'm going to turn the hairdryer on high, and it's going to blow the air over top the curved surface. And it should curve around the surface and stay to it just like it does along an airfoil if the Coanda effect is correct. As see, the pieces of paper lifted up, and that is because the air actually did curve over the surface, and since it was going at a higher velocity, it lowered the pressure so that the pressure was lower than the atmospheric pressure, increasing the lift, causing it to rise. In my AAA wing system, the way that I use the Coanda effect is I utilize it in my 3 sets of air jets, because what they do is they shoot the air over top of the wing at a higher velocity than the air that is currently going over the wing. And according to the Coanda effect, the air is actually just going to curve over the wing instead of being shot out and just weaving around and not sticking to the surface and not generating any lift. But now, due to the Coanda effect, it will generate more lift than the normal wing today. Thank you for listening to my advanced academic aerodynamic video. I hope you enjoyed the video, and I hope that it helped you learn more about the Coanda effect. Please feel free to watch more of my videos about various effects and principles. Thank you.